Hello everyone, I'm Amit Singh and I'll be presenting context switching in machine minds for the Society of Mathematical Psychology 21. Talking of the motivation and origin of the project, I was quite impressed by the neuroplasticity in brain and how it context switches from one task to another. And this is done through negotiating uncertainty with certainty and implicit knowledge transfer. What do I mean by these terms? I'll be invoking a few cognitive structures like metaphors and intuition that the mind has developed over the years through societal and collective cognition. So, for instance, if you just say Rome wasn't built in a day, it just signifies things taking time in a latent space, cognitively transferring from one task to another one. So, the model that I'm looking, the conceptual framework that I'm looking for, will be modeling the same approaches mathematically and how those transitions may uh, help help us human understanding us better. So understanding transitions, well, a transition from theta to phi, that is from one parameter space to another one, will be discontinuous in most cases, just because the tasks may not have any inherent coordinate space in common. So the gradient based optimization will definitely fail. Therefore, I'm introducing a meta latent space into the world model W, which fits really well in the world as a world model and represented in the mind. So it fits very well with that approach and very good with the approach presented in Schmidt Huber's and David Haas paper in 2018 called World Models. So the picture that you see below is just meta embeddings of different tasks, denoted by different colors, and over the cognitive latent coordinates. So let's have now a look at the model algorithm and the learning procedure that I'm using in the model. So it starts with constructing a latent space which is used and inferred variationally from a probability distribution called Q of Z. Q of Z is a random probability distribution that is inferred and optimized by the KL divergence with the initial model distribution that we have, that's P of Z. So world model W is constructed in such a way that it's locally linear, and switching from one meta task to another one is just linear interpolation. So as you can see, the picture on the right signifies how a model translation can happen through linear interpolation. And one thing to note is the space or the coordinate space that you see in red is the same energy latent. So once we go with the linear interpolation method, we can only do it when the task parameters or the meta task parameters rather lie in the same energy latent. And once you have switched from one energy latent to another one, from that is from z of theta to z of phi, constructing z of phi to z is just how variational autoencoders work. And it's not just something that's common but also very widely used in the machine learning community these days. So this is my concept and how I'm transitioning from one task parameter space to another one, and this invokes the latent space and things associated with it. Therefore I would like to conclude my presentation with an introduction to my next one, that is collective intelligence as latent imagination, which I'll be presenting in ICCM really soon. So I hope to catch you right there. Okay, thank you so much.